Okay, exercise 10F, question 1. I'm going to assume that you've read the question. First thing is that we are going to have, I'll have A on this side and B on this side. I've just drawn them at the same height there, but we don't know if they start at the same height or at different heights. It doesn't really matter. A has got a force pulling down of 4g newtons from the mass of 4 kilograms. B is 3 kilograms and it's pulling down with 3g newtons. Pulling up on A is the tension in the string, pulling up on B is the tension in the string, and it remains the same all the way through because the string is inextensible. We can ignore the mass of the string because the string is light as well. If we consider motion at A, we'll go vertically. There is an acceleration here. It says it's released from rest. It doesn't say that it stays in equilibrium, and this pulley, remember, has no friction around it. So the tension in the string is the same all the way through. It's this force here is bigger than this force here. So this thing is going to start slipping this way and accelerating. So at A, we've got 4g minus t equals the mass, which is 4, times the acceleration, which we don't know. That's equation number 1. At B, we've got t minus 3g, that's our net force. Oh, at B, vertically, F equals ma. So the tension, tension minus 3g is the force, so 3 times the acceleration, that's the mass, is 3 times the acceleration, which is just acceleration. So we've got 2 equations and we've got 2 unknowns. Now it asks us for the tension in the string, but it's actually going to be easier to find the acceleration than get the tension, I think. And when I look ahead to parts B and C, we're going to need to know the acceleration anyway. So I'm going to do equation 1 plus equation 2, and that's going to give me 4g minus 3g on the left-hand side. This minus t and this positive t cancel out. That gives me 7a on the right-hand side. That gives me g over 7 is the same as my acceleration. I'm going to call that number 3, and I'm going to, obviously you keep writing down the page. I'm just trying to squash things in so they're visible as much as possible on one screen. Sub equation number 3 into equation number 1 to give us 4g minus t equals g over 7. So 4g minus t, 4g minus g over 7. Oh, sorry. This is 4a here, so 4 lots of g over 7. 4g minus 4g over 7 equals t. So 4g is about 40. 40 divided by 7 is 5 and a bit. So 40 minus 5 and a bit. Should get us to the answer. Now feel free to fast forward just here. I'm just going to put the calculations in the calculator. So I'm getting out 33.6, which I think is the answer in the back of the book. Again, feel free to fast forward while I just double check that before I carry on to the next bit. 33.6, there we go. Lovely. So, here we go. Part B, so when A has travelled a distance of 2 meters, it strikes the ground and immediately comes to rest. Find the speed of B when it hits the ground. So, I think what we're going to need here is a new diagram. I'm going to ignore B on this. So here's my pulley up at the top, and here's the string, and here's A, and down here is my ground, and A moves with the acceleration to start with of g over 7, and I knew that from part A, and if I hadn't found it in part A I could work it out. It goes down 2 meters. Now we don't know what speed it is starting with, but we could perhaps work it out. Oh, sorry, I'm drawing the wrong diagram. when it has travelled 2 meters, it strikes the ground and immediately comes to rest. So it starts with, I'm not drawing the run diagram, this will do, it starts with a speed of 0 and it hits the ground with a speed of v. That's the v that we're trying to find. And for this 2 meters, it's moving with an acceleration of g over 7. So we can ignore what's happening with b. It's just what's going on here. So u, v, a, s, t. U is 0, v is what we're trying to find, a is g over 7, s is 2 meters. Don't care about how long it takes. And that's it, it's just a Suvat equation. So v squared equals u squared plus 2as. And we should be able to substitute that in, and everything should hopefully work. I'll go through that just in case that's where the problems are being created, but this is a Suvat thing, so hopefully if you thought of applying Suvat, you can do it. If you didn't think of applying Suvat, you can probably do it for yourself now. 2g over 7 times s, which is 2, so v squared equals 4g over 7. So v equals plus or minus root 2 root g over 7. Now v isn't going to be negative because that would rely on this kind of accelerating back in it, and before anything can happen it's going to crash into the ground. So 2 root g over 7, well, g is 10, so that is about 3 over 7 is going to be about a half, so 2 times root of a half is about 2 divided by 4 is about 2 times a quarter. So our final answer is going to be close to a half. Again, I'll just check that in the back of the book. If I'm in the right ballpark, we will carry on to the next part of the question. Feel free to fast forward a little bit. Oh dear, 2.37, right, well, we shall have to work that one out then. I will pause this video and come back to it when I've worked out what the mistake I've made was then. Sorry about that.